Hello, everybody in our Psych 2020 class. Um, sorry, I'm just checking on a couple settings there. I apologize for not being able to make it into class today. Also, sorry if I look a little disheveled right now, but it was a long night. I did want to, though, keep us up to speed, so I promise I'm going to try to go through everything that you'll need to know progressing into next week and give you some clarity on some things that might be a little bit difficult, but what you're going to probably find is this lecture won't take extremely long because we did have a couple activities that I wanted to plan for today's class and discussions that don't really work in this particular format. So if you've got questions along the way or things that you need some clarification on, I encourage you to send me a message. I'll be happy to respond via email because I do want to make sure that even though we have to do this, that it doesn't cost any of you any of the information that you're going to need to know going forward. So let's get into today's material. What we're going to be covering today is actually kind of a continuation of what we were discussing in our last class. If you were there, you probably remember us talking about how when we run experimental designs, we're comparing groups of individuals to each other, what we call levels within our independent variable across some dependent variable. And we can split up these groups into one of two ways. We can run what's called a within subjects design, where everybody is actually a part of both groups, or we can run a between subjects design. In our last class, we focused a lot of attention on the between subjects designs, talking about how sometimes these things are necessary, or sometimes there's characteristics to within study designs that kind of push us to run between subjects designs as well. But I mentioned in that class that even though this particular design might be necessary, it's not ideal. And what we would prefer to do when looking for really causal effects and being able to explain differences is run those within subjects designs. We're going to talk a little bit more about what within subjects designs are. And much like we did with between subjects designs, we're going to be focusing in on some of the concerns that you have when you're running a within subjects design study. So again, let's talk about why we would run a between subjects design. If you remember in our last class, we discussed how if there's any type of what we call major carryover effects, this can be learning, this can be fatigue, this can be practice effects, that again, it can be just straight up necessity that causes us to do this. This is why we sometimes lean on between subjects designs. In fact, a big portion of the research that people run is in these between subjects designs. But what a lot of statisticians, what a lot of researchers stress is that if you have the option of running a within subjects design, it's ideal. And to kind of give you a sense of why this is the case, we were going to do a little bit of an activity. What we were going to do is talk about kind of what are some of the benefits of running within subjects designs and kind of where the pitfalls to these within subjects designs were after first clarifying what within subjects designs are. And I was going to mention in this slide that in essence, these benefits of being able to have more statistical help, being able to have fewer samples is all nullified if you have some third variable that impacts things. But to kind of see how valuable this was, we were going to kind of go to this slide, and then I was going to fast forward to an activity that we were going to do in class. So what we were going to do with this activity is get some people to volunteer. I was going to ask for hopefully 10 volunteers, and I could split people up into groups of 5. Well, originally split people up into groups of 5. And what we were going to do is have people roll up pieces of paper and try to throw them across the room into a garbage can, trying to see if the manipulation that we were going to incorporate, making people keep their eyes open, making people keep their eyes open or making them keep their eyes closed, could impact people's ability to successfully make lots of what we would call baskets, throwing rolled up pieces of paper into a garbage can. Obviously not the most creative example that I could probably come up with, but it should have kind of hit home when we did this that when we're doing these tasks, we probably can conclude through usually what we find is that the eyes open group does better than the eyes closed group. But then we would start to look at the groups and wonder if there were any other extenuating circumstances that could have played a role. Maybe one group was more athletic than the other. Maybe one group, for some inexplicable reason, loves rolling up balls of paper and throwing them. Maybe there's some type of other variable out there that could have had an impact on the differences that we found between the groups. And what I was going to have us discuss was the fact that, when we did this activity, we just assumed that if there was a difference in the averages, that it meant that there was an effect. But with so much variability that we would probably find between individuals, the scores being kind of all over the place, the samples being so small, it meant that even if we saw differences between the groups, statistically, we'd probably be forced to just say, we think there's something. We're not certain that there is something. And this would have led us to redoing the experiment, saying, all right, let's change it up. So let's have people first try again with their eyes closed and then try again with their eyes open. And we see if there were differences in individuals' performances from the first time they did it to the second time they did it. And hopefully what we would find there is the majority of people, when they had their eyes open, did better that second time around. And this would suggest to us that we can start to be a little bit more confident in our notion that having your eyes open when trying to throw a piece of paper across the room is better than closing them. Not necessarily groundbreaking research, but it should kind of get to the point that we can have the same number of individuals in these studies and have much, much more certainty in our findings. But it also could bring us to some issues that people start to raise when talking about these within subjects designs. I'm guessing some of the people in the class would maybe raise their hand and say, well, yeah, your eyes open and closed might have mattered, but what about practice? What about when people got to throw it a second time? And this would have led us into some other discussions about concerns that we have once we've recognized the within subjects designs values and we've decided we can do it, that we have to be attentive to and kind of make sure that we're taking care. So when we're looking at the benefits of these within subjects designs, I'm hoping that that activity would have brought out to light that the fact that it really is nice in the sense that you don't need as many people to find something. And more importantly, you can be much more certain when you find something because we're looking at somebody's performance from one moment to the other versus some random person's performance in comparison to some another random person's performance. And that is always an inherent problem in the between subjects designs. It also means that when we find differences in averages, we can start to be a lot more confident in what we call between group variance. The other cool thing with this is that, in some studies we run, we're running between subjects designs, we might find a ton of variability within the different groups, and in fact, inconsistent variability within the groups. So if we're going back to that paper throwing example, sometimes what we find if people are throwing 10 shots is that some people are hitting 6, 7, 8 of them because they've done this a lot or they just are very focused, and others are hitting 1 or 2 of them. And in other groups, everybody's hitting almost the exact same number, especially in the eyes closed group where people are lucky to hit 2 or 3. So we've got one group with a ton of variability and another group with very little variability. And this also is a big problem in our statistical analyses. It's going to be a big problem when we talk about our certainty of our findings because people start to wonder if you're just grabbing a random subset of the population that happens to have an average where they're at, when you see that much variability in groups, especially when it's just one group that has a ton of variability. We call this within group variance. And this is a part of many statistical test calculations that we run. And it's something that will be a concern when you're running between subjects designs. So again, it pushes you towards those within subjects designs. And hopefully from that, we would have seen the highlight of why these things are so valuable. Again, there are dangers with this. We talked about practice possibly being an issue with that paper ball throwing example that we were going to do. There's other issues that could sometimes matter when you have a little bit more spread in terms of the time that you're doing things. So one thing that can definitely happen is that there can be kind of random differences between the sessions when people are being run, even if it's the same people that are impacting performance. Right? It could be that the time of day is impacting somebody's ability to do a task, even throw a piece of paper. It could also be the person testing another individual. Right? You might do this activity where you're testing it with 2 different administrators, and one is kind of gently moving the garbage can or the basket towards the balls, and somebody's suddenly making a lot of shots, where the other one is keeping it dead still, or even in a horrible way, moving the basket away from the balls. If those differences between administrators are there, that can really impact performance, even if you have the exact same people. So there's still a big need for consistency within your study, even if you're running within subjects design. In fact, some researchers argue it's even more critical when you're running within subjects designs to have complete, absolute consistency so you can really attribute any differences you find to those manipulations that are there. There are other some kind of big picture effects too that can be of concern. Most of these, though, deal with studies where you're looking at within subjects designs over an extremely long period of time. So if, say, some current event shifts everybody's attitudes about something or shifts people's perception about something, well, then what you might find is that, yes, your manipulations are seeming to be linked to differences in certain scores, but maybe there's nothing to do with the actual manipulations that you're doing. Let's say you are really interested in researching political trust, whether or not people trust their politicians. So you give them a story about a politician that's doing something slightly unsavory and then asking how much they trust politicians. And then a month later, you bring them in and you give them a story about why some politician is really helping out his or her community and ask the person again how much they trust politicians, assuming that those stories could impact people's trust of politicians. Well, that's a great idea, but let's say something crazy happens over a month where there's a whole bunch of random things happening in our political world that cause a lot of mistrust of politicians or cause a lot of people to kind of get riled up over politicians that has nothing to do with those instructions being given in the experiment. Well, that might cause over that span of time a change in people's perceptions that again has nothing to do with the manipulation being done. And this obviously doesn't happen very often in very short time spans between the different conditions that people are in, but when you have to spread them out, this is a concern that sometimes pops up. Same thing with things that are testing kind of cognitive abilities or specific skills. And as people get older, especially when you're testing young kids, you can see improvements in performance that maybe has nothing to do with tweaks in instructions or tweaks in the design, but instead just has something to do with maturation. The child's getting better at all skills, and that's being reflected in the performance on these tests. Another thing that can happen, and this is a weird one, but it does occasionally happen, is the instruments being used can decay, right? You can have things that are measuring reaction time lag a little bit. In a lot of cognitive studies, a fraction of a second lag, a tenth of a second lag, can just completely obliterate the efficacy of those studies. Other times you could just have not instructors, sorry, researchers or research assistants lag a little bit, change their perception of things over time. So you're running people in the same study, but the same action of a person is no longer seen the same way as a result of tweaks or changes in the observers that are measuring something. This actually happens a lot in emotion research. When a research assistant is looking for emotional expressions in faces and the extremity of it, what consistent studies have found is that that research assistant does not see the same smile the same way over time. They kind of drift in different directions. And that can be a big problem. Again, if you're exposing somebody to different events and you're assuming that any changes that they're displaying or that you're measuring at least are a byproduct of the changes in the environment or what you're tweaking, it suggests that maybe there's other things at play. Another thing that can happen, and we've talked about this before, is learning. It could be that you learn that specific task more, or maybe there's outside information that's kind of been encountered since the first exposure, the first level, first test of the experimental study, and that's caused the person to actually perform better the second time around, even if there isn't supposed to be any major carryover effects. But this does get us to one other thing that's kind of a big issue. If testing and learning is robust and it's directly related to what's going on, that's what we call an order effect. And it's something that really prevents you from ever being able to run a within subjects design. So if somebody's naturally getting significantly better on something the second time around, then you can never really run a within subjects design and see, how different instructions or different sets kind of impact performance on those things. The classic example of this is giving somebody some type of study method, having them take an IQ test, and then giving them a different study method and having them take the same IQ test a few weeks or months later. Not only do you mature a little bit, but having taken that previous test makes you significantly more inclined to do better the second time around. And that's a big problem. And it brought a lot of people to this notion that we first have to, when we're running our studies, when we decide if we want to run a within subjects design, determine if there's any just obvious order effects that are going to prevent us from being able to run those studies. And if we do find them, it does really push us to run those between subjects designs. But there are some order effects that are out there that we can sort of control for. We can sort of manipulate if we know what the exact effects are going to be. And we call these types of order effects carryover effects. We'll talk about those in the next slide. So we're looking at, again, order effects that don't really have the ability to be overcome, and they're going to give us differences that have nothing to do with the manipulation. We're kind of stuck. But if we have carryover effects that change performance in a very predictable way, what we can do is actually tweak our measurements, tweak our analyses to kind of take into account those particular order effects. And this is really critical, especially in studies where a bit within subjects design is kind of necessary, where we really don't have the option of running a between subjects design. Now, one of the ways you can look for these things, if we're talking about order effects, is to look for what we call variance consistency in measurements. I think I tweaked this for those of you that printed the slides out. There's a slight change in the term there. Variance consistency in measurement just means that what we're looking for is that the spread of scores between groups is, again, the same. There's different types of tests that can tell you about this, one we call the Levene's test. And we're also looking for, if we're exposing somebody the same thing twice, that are the same averages between those exposures. So this involves usually pilot studies, exposing somebody to the same condition twice and seeing if there's any improvements over that second exposure, and looking at, when you're exposing people to different things, whether or not, again, you have that consistent variance from group to group. If you start to see problems with this, this leads you to usually want to kind of take into account what you can do to kind of counter this. One of the ways you can do this is through what's called counterbalancing. So when you've got two different conditions, what you can sometimes do in your within subjects designs to kind of overcome some of the less robust carryover effects is split up your group of individuals for your study, but still going to be a within subjects design, and run half the group in one condition first, and then the second condition second, and the other half of the group, you're going to run them in the second condition first and the first condition second. And by doing this, what it does is kind of balances out the averages a little bit, takes into account some of the tweaks. It's not very good if we're looking at how these things affect individuals, because you're going to get some weird wonky numbers, but it's kind of an alternative way of overcoming some of the side effects that we see with these carryover effects when we have to run within subjects designs that inherently have these things. However, there's some other ways we can kind of mathematically tweak things that are really cool. Well, my favorite examples of this, that the kind of we could use this counterbalancing to really look at it, and also just use it so we can look at how these things might affect an individual, came from a very widely distributed test called the IAT. Some of you might have taken this over the years. It's a test that it says it actually looks at people's implicit biases for or against specific groups. There's also new ones that can be used to look for mental health statuses and other things. And there's a lot of caution that people usually use when trying to incorporate these into different measures, because the consistency of these is a little off, and whether or not they're very predictable is debatable. But one of the things that the IAT has done, which is very admirable, is they've really taken into consideration how carryover effects could impact people's performance. So what they've done with the IAT test, when people are being tested for specific biases, is they've run a ton of pilot studies on each test to see how changing from one condition to the next impacts people's performance. So what you see with the IAT is people are given lists of words and faces, as you see. This is one that's looking at race and biases that people might have. So you'll sometimes see a face popped up on the screen that's either black or white, or words that are popped up on the screen that are good or bad. And in each condition, black faces are paired with bad words or good words, and white faces are paired with bad words or good words, depending upon the condition that somebody's in. And this when you see black faces are being paired with bad words, and white faces are being paired with good words. And you're supposed to, in this test, kind of categorize these faces with either the letter E or I, E being on the left-hand side, I being on the right-hand side, as quickly as you can, depending upon what you see. So in the upper left-hand corner, or the lower left-hand corner, I guess you see a black face, so you're supposed to hit the letter E. In the right-hand corner, you're supposed to, because it's a positive word, hit the letter I. Now, what they do with this test is after you've done this sorting task in the manner that you see depicted here, is they flip it. So then white faces are paired with bad words, and black faces are paired with good words. Actually, that's, now that I look at it a little bit closer, what we see on the bottom. And this sorting task is done to kind of see if people respond faster and better, without making as many errors, that is, in one condition or the other. Assuming that your brain is easier, more capable of doing one of these tasks if you have a bias of pairing one type of words with one particular type of group, or one particular group of individuals. The catch to this is, though, that once you practice for a while, there's some carryover effects. You usually go much faster the second time around, but as you're going faster, you also make more errors the second time around. So what they've done is counterbalanced this so many times that they know exactly what to expect from people who don't seem to show any biases whatsoever. So if you're testing on the same thing a second time around, or just using random things where there shouldn't be any attitudes linked, we know how many extra errors you should make the second time, how much faster you should react the second time. So when people's scores are measured, what they're able to do, because they've counterbalanced so much, is take those differences in performance that we'd expect to see into account. So you'd have to make way more errors the second time around for us to say, well, those extra errors are indicative of a bias. Or you'd have to respond way faster the second time around for us to say, that's indicative of a bias. And that's what the IAT test contends they do, to measure these biases, to measure these attitudes. It's an interesting idea that hopefully gives you a sense of what we can do if we have to run, like we see here, a within subjects design that has possible carryover effects that are at play. Sorry for that little delay there. Um, so real quick, obviously we've been spending a lot of time talking about the match subject, match subjects within subjects designs, but I did want to point out there is actually one alternative if these carryover effects or other types of third variable problems are so impossible to overcome. Between subjects designs aren't sufficient. And it's something that we call a match subject design. We kind of alluded to this earlier in our last class, this notion of trying to find people that we think are kind of comparable to each other and then placing them in different situations. Now, a true match subjects design usually has specific qualifications that we're looking for. So, if height matters, we find people that are the exact same height. If age matters, we find people that are the exact same age. If some type of education matters, we look for people that have the same exact type of education or number of years of education or maybe same GPA. Whatever it is with match subjects designs, we have to know kind of intuitively before we start the study what characteristics are possibly third variables that might cause differences between the groups that we see, so we can pair people up across those particular characteristics. The benefit of doing these match subjects designs is we can treat a lot of the analyses that we're going to do on them the same way we would run a within subjects design analysis. It's going to get complex in the math stuff as you move on, so I'm not going to go overboard here today. But know that essentially, even though you need twice as many people as you would need in a within subjects design, a lot of the mathematical tools you use in a match subject design is the same as the mathematical tools you use in a between subjects design. And that's kind of a cool benefit of this particular study type, even though most people don't run them that often. And this is one of the things I kind of want to close out with, just so you can get a sense. But there's a lot more out there that you're going to learn about. But the main contrast between within subjects designs and between subjects designs is something that you want to be acutely aware of as you're progressing, because it's going to be something that keeps popping up in future classes. Now that we've covered that, it's time to move on to some other kind of interesting types of tests where our designs aren't as straightforward as the ones we've covered. We're going to be talking about things called parametric tests, time series designs, correlation tests, and all this will be covered next week. So make sure that you do your studies for this week's stuff, do your readings for next week, and I will see you on Tuesday for our class. Thanks, folks, and again, sorry for this format and any distractions that might be going on that I'm not aware of. Take care.